So now let's redo the same with exercise 2.2. Now we have r is equals to 9104, and then in the UR, and then we have v vector, which is equals to negative 0.7004 UR plus 6.1422 U theta mu, not mu, U theta. There we go. Now let me just go back into my code, and I'm gonna pretty much just change initial values, and I'm gonna call it a day because that's all I need to do really with the code. Anyhow, so this one now is equals to 9104, and then we have velocity to be negative 0.7004, and then I have 6.1422. Okay, now again I'm gonna write the formulas to find h vector, find r cross v, and then I can find the magnitude of h by just squaring h and then square rooting it. Then what else was us to find specific energy, which I use v squared divided by 2 minus mu over r, and then I have semi-major axis, which is then going to be equals to negative mu over 2 theta, coming from zeta is equals to negative mu over 2a. Then I have parameter p, yep, which is equals to h squared divided by mu, the magnitude of h squared, of course, not the vector. I have eccentricity, E, which is equals to 1 minus P over A, everything on the square root. I have perigee, which is equals to A times 1 minus E. I have apogee, which is equals to A times 1 plus E. Then I have flight path angle, which is equals to cosine power negative 1 of H divided by RV, everything magnitudes here, as you can see the notation. And then the true anomaly, F, which is equals to P over R minus 1, everything times 1 over E, eccentricity. And this is the R cosine, so cosine power negative 1 of this. Let's try to see if as much as I can do one single screenshot. No, I cannot do one single screenshot, but I can just copy paste like this. Okay. Hit the clipboard. So these are my answers in order. Oh, maybe I should. Okay. Okay, it's a big image, I guess. So these are my answers. I'm gonna check it while this other image is pasting. So I have 55,000, yeah, eccentricity is equal to 0.1697, yep. And all the other stuff, I'm gonna check in a second. Oh, I never printed zeta, but it's there. You can run the same code and print it yourself. And this is the final answer with the my zeta being 144. Why is the answer 144 is actually incorrect? Why so? Because when we look at cos gamma, we're not actually finding out, well, when doing the arc cosine of an angle, we're not actually finding out whether it's positive or negative. Remember, it can be both. So one thing we need to make sure is to do the quadrant check. Now, interestingly, the velocity vector has a negative UR component. Therefore, it's going to be pointing inside towards the center. So if this was the ellipse, where I have perigee here, I have my focus here, I have apogee here, apogee, perigee, and my focus there, then it means that we're past the 180 degrees, so the angle is actually negative. So the gamma will be a negative value here. Let me do it in red so it's clear. And a negative value here. If you want to just write it in nicer terms, you could do 360 minus the f that we have, which gives us 205 degrees. Yep. Sorry, no, 215. I'm not sure why 205. Yeah, because 360 degrees minus 144 is equals to 6 here, then we got a 1 here, and then we got a 1 here. Yeah, 2 here. 216 degrees. Technically, this one should be around 245, so 215. Oh, because we're 215, 360. Yeah, 215 degrees.